Hello everyone, welcome to Algebra Made Simple / Math Made Simple. I'm going to say / today because I'm hitting a topic that's really more for, really it's both and both. You know, you got algebra kids who are dealing with this challenge for a lot of kids, where you have to divide a polynomial, and you have to do that using two methods, but one of the ones that gives kids the most trouble is called dividing by long division. And so I was just teaching long division to a kid who's a little younger, not quite ready at the algebra level, and they needed to fill in some gaps, and I thought, well, why don't I do a hybrid? I'm just doing a topic on how to divide using long division, and this is both at the elementary level and at the high school level. This is going to be very helpful for a lot of people out there struggling to learn this, and so I want to go ahead and get into it. So I have two versions I'm gonna bring up on the screen, and so I'm going to go ahead and show you this now. This is, you can find this worksheet, by the way, at software.com. They have a lot of good free a lot of good free worksheets. This one is a polynomial, but before I do that, I really want to start with just doing old school long division, because honestly, by the time kids get to like 9th grade, maybe the first time they've done this, maybe at their high school, 10th grade, they forgot about long division. They haven't had to do it in a long time, and you know, maybe it was 5th grade they did it a lot, but it's been like 4 years, and so they might need a refresher just on those basic processes, right? So what I want to do is I'm going to pull up, if it'll give me a second, there we go. I'm gonna show you and remind you how to do long division, just doing it that way, and this will be helpful for kids who are trying to learn that skill themselves, but then hopefully it'll also give you the foundation that you need for doing the polynomials, okay? So what I want to do is first talk about this. When you do long division, you always want to ask yourself, does the divisor, you know, the thing we're dividing by, let me see if I can make this a little skinnier, maybe I can't. Anyway, does the divisor, can it be going into that first digit that we're dividing it by? You know, some people call that, I believe, the dividend. You know, 716 is being divided by 7. So what I say is just look at the first two digits. 7 goes into 7 how many times? I wonder how many times that is. Well, give it some thought, but hopefully you'll figure out that it goes into it one time. So 1 times. It goes into it. So you put a 1 above the line, and if you remember from earlier grades, or maybe this is the first time you're learning this, as soon as you put a number above the line using long division, you have to multiply it back down by the divisor. So we're going to do 1 times the 7, and we're going to do that, that's 7, and we're going to write that underneath that first digit, okay? So you want to multiply that out. Once you multiply that down, you then draw a line, and you want to subtract the 7s, you know, whatever those first two digits are. So you got 7 minus 7 occurring right here. So we want to do that. 7 minus 7 happens to be 0, and, well, there you go. After you do the subtraction, what we want to do next is we want to bring down the next digit from here. So after that, you're going to have a 1, and if you think about it, this can be a little difficult, right? Because how many times does 7 go into 1? Geez, I mean, it's kind of hard to figure that out. I guess it goes into it 0 times, right? Because you can't multiply 7 times, you know, anything to get 1. So we're going to do 0 times 7, and that's the next move. That next digit gets multiplied by the 7 as well, and that's going to become 0. So I'm going to bring that down, subtract it. That's still going to be 1, and then we bring down the next digit, which would be 6 here, right? So now you look at it. This is where it's interesting. You look at it like, how many times does this digit 7 go into 16? Okay, oops, looks like it scrolled a little bit when I did that. Let me zoom out and see if y'all can see that. There you go. Hopefully you can see that a little bit better. How many times does that 7 go into 16? That's what you're going to ask next, and hopefully give it some thought. Well, 7 times 2 is 14. That's pretty close to 16, so we're going to say it goes into it 2 times, right? Goes into it 2 times. So it's just like I said before, if you have a number above the line, you want to multiply it right back down again. 2 times 7 is 14, so we're going to put a 14 underneath the 16, and as soon as you write a new number down there, you always subtract those two. 16 take away 14 is 2, and there's nothing else to bring down, so we're done here really. What we say is that this is 102 with a remainder. Let me see if I can erase some of this stuff. It might be kind of hard to see. That's doing a weird erase job. I'm going to get rid of that. Anyway, 102 is our answer, and the remainder would be 2. So in other words, you can't really divide 716 divided by 7 evenly. I mean, you think about it this way. Let's say you had 716 cookies. That's a lot of cookies, okay? Let's say you had 716 cookies, and you're dividing that by 7 because you wanted to give 7 friends all the same number of cookies, okay? Well, you can't really do that is what we're saying. What you could do is take away 2 cookies, bring it down to 714, and you can divide 714 by 7, and everyone will get the same number of cookies. But if it's 716, it's not really going to work out to where everybody gets the same amount. So we say we have a remainder, have 2 extra cookies at the end, and that's kind of how you look at it, right? So you might want to see that one more time, because I know for some of our learners, this is the first time you've seen this. Look at number 2 right here. Now, using that logic, you always want to start with the divisor 8 in the first digit that's being divided, 511, right? Well, you have to ask yourself, can 8 go into 5? No. 8 times 1 is still 8. I mean, you really can't. So when that happens, you actually want to look at it like a 2-digit number. So if 8 doesn't go into 5 as a 1-digit, you want to look at it with a 2-digit number. So now the question is, well, how many times does that 8 go into 51? And you have to think about it. But hopefully you'll come to the conclusion that, well, it goes into it 6 times, because 6 times 8, we got to do that next, multiply it, right? 6 times 8 is 48. It's not quite 51, but it's pretty close, right? So we're going to say it's 48. When we subtract the difference there, 51 take away 48 is 3. Once you do the subtraction, you bring down the next digit and you kind of start over again. That's the pattern, right? So now that becomes 31, and you got to ask yourself, well, how many times does 8 go into 31, right? How many times does 8 go into 31? Think about it. 8 times 3 is 24. 8 times 4 is 32. That's a bit too high. So the most we could say is it goes into it 3 times, right? So 3, we have to then multiply by 8, put it underneath. 3 times 8 is 24. You put 24 underneath. Remember, as soon as you write something down there, you got to subtract the difference. 31 take away 24 is, I think that's 7. And there's nothing else to bring down, so once again, we have a remainder here. So if there's a remainder, a lot of times when you're learning, you're going to learn to put a little r there, saying with a remainder of 7. In other words, you can't take 511 and divide it evenly into 8 equal groups, right? But you could take away 7 and then start from there. That will divide evenly, and that's kind of how that is, okay? So you saw 2 looks there. I want to do one more, if you can bring this on screen. Take a look here. This is another one where if I start with the divisor 7, and you start with that first digit, 7 does go into 8, not many times, but at least goes into it 1 time, right? As soon as you put the number there, you got to multiply it right back down, right? So what's 7 times 1 or 1 times 7? That's 7. Once you do the multiplication, you have to subtract what's there. 8 minus 7 is 1. You almost want to bring down the next digit after you've performed the subtraction and ask yourself, well, how many times does that same 7 go into 10 now? Well, 7 goes into 10 1 time as well. So multiply it right back down. 1 times 7 is 7. Do the subtraction. Hopefully you're kind of catching that pattern. 10 minus 7 is 3. Bring down the next digit, and that's going to make that 3 become a 34. One more step. How many times does 7 go into 34? 7 times 5 is 35. That's a bit too high, right? So if it goes over that number, 34, you got to go on underneath by 1. So we're going to do 7 times 4. That's the most it'll go into it. 7 times 4 is 28. Write that underneath. Subtract it out. And 34 take away 28 is, I think, 6. So this one, all these had remainders. And so sometimes they divide evenly. If you get a 0, that means it evenly divides. It really doesn't have a remainder. But here are our answers. You'd have to say 114 with a remainder of 6 for number 3. You'd have to say 63 with a remainder of 7 for number 2. And then I can't remember what the other one was. Looks like it was 102 with a remainder of 2. And that's how you do basic long division. If you're basically in grade school, by the time you're about 5th grade or so, you really want to have covered long division. If you're a homeschool parent, you definitely want to have covered long division at this point because of where they're headed. Math builds on itself. So I want to go ahead and jump to what you might see at the algebra level, okay? Now, depending on the schedule, the school district, the curriculum, you'll cover this maybe the first semester of a year in an Algebra 1 course, maybe the second semester of an Algebra 1 course. Depending on situations, sometimes you don't even cover it till Algebra 2, but this is an algebra topic, and it's first brought up in the Algebra 1 curriculum for the most part. Notice it's giving you polynomials. A polynomial is just a series of terms separated by addition or subtraction. And you're asked to divide those, and we're learning how to do it using what's called long division. And you'll notice there's very similar patterns. I'm going to zoom in here just so I have plenty of room to write this, and then I'll zoom back out again, right? So you want to take the first thing on the left, which was m squared, right? Minus 7m. Hopefully I have given myself enough room here. I just realized I don't have much room, but anyway, hopefully we'll squeeze it in. Minus 11, okay? And what I want to do is divide that using long division. That's a pretty ugly division bar, but that's what we're going to do. Divide it by m minus 8. I mean, that's what it says to do, but first we just want to set it up as for long division. So excuse me if it's kind of hard to see. I might have to write my answers up here or something because Apparently, I got a little too close to the original problem. Apologize about that. But you do it the same way. You do it in a very similar way, right? So the only difference, though, is with polynomials, instead of doing like the first digit compared to the first digit, what you want to do is the first, I would say the first term in your divisor and your first term by the thing being divided, right? So the question becomes, how many times does m right here go into m squared? How many times does m go into m squared? And hopefully you give it some thought, you realize it goes into it m times. I'm just going to put it way up high so I don't, have to squeeze it in between there, right? It goes into it m times. In other words, if I were to multiply m times m again, I'm going to get m squared. That's kind of how you know. So just like with normal long division when you're in like 5th grade, once you find out what that is, it goes into it m times, you multiply it right back down. But this is a 2-term binomial, so you got to multiply that m times the m and the minus 8 right there. That's the key. Think like distributive property. So m times m is m squared, right? And m times negative 8 is minus 8m. Okay, but it's still the same format if you think about it. Now, just like we do long division when we're in like 5th grade, you then have to subtract the top from the bottom here. Now, it can be a little confusing because if you subtract a binomial, sometimes it's a good idea to put it in parentheses because you got to notice that there's a double negative happening, right? M squared minus m squared is 0. And watch this, negative 7m minus negative 8m, that's a double negative there. That's really the same thing as adding, okay? So it's really saying negative 7 plus 8, which is going to be 1m, okay? Or just m, honestly. I mean, if it's 1m, you might as well just say m. So I might just write it as m, okay? But I will share this with you. There's a little trick. I used to tell kids, in order to avoid that double negative confusion, as soon as you do it this way, I say draw the line, change the sign. If it's a negative, make it a plus. If it's a plus, make it a negative. Then just add it as it looks, and it's usually easier to minimize mistakes. Negative 7 plus 8 is 1m. So either way you look at it. And just like with the other long division problem, as soon as I do the subtraction part, I have to bring down the next term. And so now you're going to ask yourself, well, shoot, how many times does m go into, I'm talking about this m right here, go into this m? Well, it goes into it, let me zoom out a little more because I'm running out of room, it goes into it 1 time. So I'm going to say plus 1, right, because it goes into it 1 time. You multiply the 1 back by each term there. I know it's kind of hard to see there, but that's what you do. It looks like a rainbow. 1 times m is m. 1 times negative 8 is negative 8. But remember, you either subtract what's at the bottom or do my little trick, draw the line, change the sign, right? That's the easiest way to do it in my opinion because those cancel out. Negative 1 plus 8 is positive 7, and 7 would be your remainder. So it looks kind of ugly here because I got too close to it, but your final answer is m plus 1, just so you can see it without all the arrows, right? And the way you do remainders with polynomials is kind of interesting. The remainder, by the way, is 7 down here, but the way you write it technically in algebra is you say plus 7, and then you put it over the original divisor, which was m minus 1, excuse me, m minus 8, excuse me, and that's how you write it. Kind of think like when you were in elementary school and they taught you how to put your remainders as fractions. The remainder became the numerator and the divisor was the denominator. It's kind of how you convert improper fractions to mixed fractions. You do it that way. It's the same kind of concept there, okay? So I want to do at least 2 of each because especially polynomials, there's kind of a lot going on, and I will try to write where there's plenty of room here, okay? Hopefully this will help. So if we got n squared, we're looking at number 2. N squared minus n, you got it minus 29, all right? Minus 29, and you're dividing that, gotta make sure I have room here, by n minus 6, right? Well, just like I said last time, you want to start with the first term and the divisor and compare it to the first term in the dividend, right? The thing being divided. So how many times does n go into n squared? Well, it goes into it n times. How do I know that? If I multiply n times both terms, it should match up, right? So we're going to do n times n, which is n squared, or n to the power of 2. And n times minus 6 is a minus 6n. At this point, I think the easiest thing to do is I draw the line, change the sign. It's the same thing as subtracting it. It's just a little easier, right? N squared should cancel out, and negative n plus 6n is positive 5n. After I do the subtraction, or the draw the line, change the sign, I bring down the next term, which in this case is minus 29. Okay? Now I'm starting over. I'm saying, well, how many times does this n over here in the divisor go into 5n down here? That's what I'm doing next, right? Give it some thought. Well, n goes into 5n, I think, plus positive 5 times. We're going to say plus 5. Okay? Once I find that out, I got to multiply that 5 by both terms in the divisor again. That's kind of the pattern. You put something above the line, you got to multiply it back down. So 5 times n, I'll try to zoom out. Hitting the wrong button here. Let's zoom out just a tad. Okay, that's going to be 5n. Forgive that little dot there. And 5 times negative 6 is negative, I think that's negative 30. Just slowing down a bit. Draw the line. Change this sign. And so that's going to cancel out. Negative 29 plus 30 is 1. So that's my remainder down there. It's going to be a remainder of 1. And remember, when it comes to polynomials, you want to put the 1 like that. Numerator and the original divisor n minus 6. And that's a lot like mixed fractions or going from improper fractions. So your answer's right there. It's n plus 5 with a remainder of 1. And that's how we write it. Okay? So anyway, this is just a quick review on how to do some long division from some of my current clients who happen to be dealing with this a lot, and I'm seeing it at the elementary level. I'm seeing it pop up again at the high school level, and so I wanted you to see the connection, hopefully you saw it, between how to just do it like old school, like you learned when you were in elementary, and it's really the same pattern just with polynomials and having to kind of expand your thinking there. But hopefully that was helpful. Let me know in the comments below. Good luck in the classroom. I'll catch you on the next one. Peace.